Hi, my name is Madeline Cuellar. I am doing Unit 1 of Semester 1 of Math 2. And here is my assignment. Unit 1 is on the features of functions, which takes something, the input, and produces a result, the output. The functions have tendencies and rules, and this unit shows these. The first function the unit goes over is the absolute value function, which takes any number and tells you how far that number is from 0. So the absolute value of -6 equals 6, and absolute value of 8 is 8. You can use the absolute value functions to solve how far my throws and discus could be if I wanted to be within 5 feet from my best throw, which is 109. So the absolute value of x minus 109 is equal to or less than 5. Just so. This function represents problem solving. We break it up and do basic algebra. We have absolute value of x. We have absolute value of x minus 109 equal to or less than 5, right here. So we're gonna break this into two parts. First part will be the simple part, which is x minus 109 equal to or less than 5. We're going to add 109 to both sides, because this is a negative right now, minus. So we're going to take away 109, and then, pretty much, yeah. And we're going to add 109 to this 5. This will be non-existent, will become non-existent, and we'll have x is equal to or less than 114. For the more complicated version of this, we're going to have negative x minus 109 equal to or less than 5, and we're going to divide all this by -1, both sides. Yeah. And then we'll have x minus 109 equal to or less than 5, -5, which is same over here, except this is non-negative. We will add 109 to both sides, and then we'll have x is equal to or less than 104. Our final solution would be 104 is equal to or less than x equal to or less than. My throws have to be at least 104 or more than or equal to 114 to be within 5 feet of my personal best. Understanding properties of exponents is important because they are often in functions. So we have f parentheses x equals 3 over 2x square root 3 square root -2. We need to be able to understand not this function better. We need to understand this function better by using the number of exponents. So this is going to be one of our examples. There you go. So we have 3 over 2x, 3 to the x to the power 3 to the power of -2. We're going to break this apart into two parts. Into 3 over 2 to the power of -2 and x to the power of 3 to the power of -2. After that, we need this to be a positive, right? So we will swap the numerator and denominators places, and that will turn this root into a positive. And we have two roots over here, the 3 and the -2, so we will multiply those and get x to the power of -6. For this next part, we have to split the root, into both the 2 and the 3. So we will do so by having 2 to the power of 2 and 3 to the power of 2. And we need x is a whole number, but we need it to turn into a fraction. So we will put a 1 over the x to symbolize x as a fraction, and we will bring the -6 down and turn it into a +6 because we're turning this into a fraction, and it basically swapped places with a 1 because we turned it into a fraction, it turned positive. We will then multiply these, so 2 times 2 is 4, 3 times 3 is 9, which will leave us 4 over 9x. And when we go to multiply these two, since this is a 9 now, and this is now a 4, it'll be 4 times 1, 4, 9 times x to the power 6, that'll be just 9x to the power 6. So our final answer would be fx in parentheses equals 4 over 9x to the power of 6. This helps us in many ways. Again, my name is Madeline Quidar. This was for unit 1 of semester 1 for math, and